All right, so what's going to happen here is we are obviously going to be using substitution or elimination. Some of them might be ready to go for substitution, but some of them are not as easy as this one. I'm starting with one of the easier ones and then we'll go and get harder, okay? But again, using a piece of paper, showing your work, less likely to make mistakes, okay? Please do not try to do these problems in your head. I can't even do them, okay? If I look at this problem up here, again, the 3 by 3 comes from, usually there's 3 equations with 3 variables, so we're no longer just solving for an x and a y. We are going to solve for x, y, z alphabetically, so we will have an ordered triple instead of an ordered pair. Will we be expected to graph 3-dimensionally? No, but I can show you that if we have some extra time, okay? This one, nice and neat, okay? Because I already have one of my answers. Okay? I told you just a second ago that yes, we're trying to solve for x, y, z alphabetically, and we just have one of our answers, which is nice. Okay? We need to find the x and the y. Well, I can substitute that z in and find another variable. Where can I substitute the z in and find another variable? Yeah, in this second equation. Since this says z, I can substitute into the second equation where I see a z and solve for what variable? Y. And then we can take my z and my y and substitute it in the top equation and solve for x. So we're going to do just that. We're going to take that second equation. I'm going to kind of go up here. Y plus 2 times the z of 5. So this one is using substitution. Most of the time we're going to do a double elimination and then a substitution, and I'll explain that when we do a little harder example next time. And then we have equals 13 still. And we're going to go ahead and work it out for y. So it looks like we have y plus 10 equals 13. I'm going to subtract 10 from both sides, and we get y equals 3. Is that good math? Yeah? Now we're going to take that y and that z, and we're going to substitute them into the top equation where I see y and z. So we're going in here and here. And I'm going to go down here since I have a little bit of space. Well, let's see. All right. 2x is 2x negative 3 times my y, which is 3, plus the z, which is 5, equals 10. All right, doing the math, 2x minus 9 plus 5 equals 10. We can combine like terms. So 2x minus 4 equals 10. I can move my 4 over. What I do to one side, I do the other. 2x equals 14. And dividing by 2 gives me 7. And we just found our ordered triple. All right, that one is a fairly easy one. It was set up nice and neat, okay, for substitution. Once we had one answer, we took it and substituted into the second equation for 2 variables, and we only had the one that we had to find, and then we took the 2 and went into the original. All right? We like those. Those are fairly easy. Let's go into one of those harder ones. All right? I'm going to call that example 1. Example 2. Let's see what we got here. First things first, I want to make sure my positive negatives are correct here. Okay. Now, this is a little bit harder of a 3x3 because we have 3 equations with all 3 variables. The other one was set up nice and neat that we could do substitution, okay? Most of the time we have to do a double elimination method. So what I want to do is look at all 3 equations, and you get to choose. Do I want to eliminate x? Do I want to eliminate y? Or do I want to eliminate z? Okay? So when you look at that, you get to choose. You might think differently than your neighbor. You might think differently than the teacher. As long as we have correct work, we will get correct answers. Sometimes just taking a little breather and saying, what do I want to eliminate, might be beneficial. But all 3 of these variables are pretty darn easy or nice to eliminate. So I do not care truly which one. But you can only look at 2 equations at a time, but we have to eliminate the same variable out of all 3 equations. So do we want to choose x, y, or z question mark?
What I did, I know 5 and 10, 15.
X?
Okay.
Yeah, passes around the backboard there. So I heard an x. Anybody else with that person for an x? I would be. Anybody for a y? Sure. Anybody for a z? Sure. But since I heard an x, I'm going to go with x. Now, I know that if I look at the first and the third equation, they're already ready to eliminate x's, right? How do I know that? Okay, say again. So when I look, he said they're opposites, meaning I have a positive x here and I have a negative x here. They're ready for elimination. So I'm going to go ahead and write those off to the side. We're not changing them. So I'm going to have my x plus 2y, just to keep my work all nice and neat, equals 3. I'm taking that third equation underneath it. Whoops, it's a minus. My mistake. Copy error. All right, and now we are ready to add them together. We were talking about x's. X's are positive, negative. They'll cancel out. Y's cancel out. Z's cancel out. Meaning, what number do we have over there on the left side? 0. I do the math here. What do I have on the right side? -3. Remember that we have special cases of the 2x2's, which are no solutions or infinitely many. What would this one be? No solution. Because why? Right. 0 doesn't equal that -3. So on this one, we would have a no solution. We don't have to go any further. Okay? So sometimes that happens as well. Does it happen all the time? Of course not. How do we tell if something isn't infinitely many? They equal one another. I would have 0 equals 0 or negative 3 equals negative 3. It would be a true statement if it's infinitely many. All right? Let's look at another one. All right. Let me make sure I have my positive negatives correct. Okay. Similar to the last one, we have to scan through and we have to decide, do I want to eliminate X or Y or Z? Question mark, which one? X? Anybody agreeing with her? I do. A little less work, I think, on the X. Now, don't forget, some of us are breaking that little no technology during a teaching moment. We shouldn't be on our phones. We shouldn't have earbuds in. Okay? Keep in mind that we focus on the math that's going on. While we're here, I do have the right to take those. Okay? So keep that in mind. Earbuds out, cell phones put away. X, I want to eliminate X. I can look at which two together and eliminate X right away. The top two. So I'm going to go ahead and look at these two right there. I'm going to write them off to the side so we keep our work all nice and neat. So X minus the 6Y is staying the same. My negative X plus 5Y staying the same. We're ready to add them together because they are already positive, negative. X's cancel. I like it. Oh, this one's not all nice and neat like that last one. How many Y do I have left? Negative 1Y. How many Z do I have left? Negative or positive? Positive 1Z. Do you have to put the positive 1 and the negative 1s? Not really. You could just do positive, negative. What do we have left with the numbers? Negative 6. All right. So we let that sit for a second. We've got to eliminate the X out of that third equation. Remember I said we have to eliminate one variable from all three equations unless something particular happens like that second example. Okay, we like those when that does happen. But this one's not happening that way. So again, I have to get rid of the X in the third equation. Do I want to look at the first and the third together? Or do I want to look at my second and my third together to eliminate X? Second and third, I like. Okay, so I already have a negative here, but I need to get that 3. So what do I have to multiply that middle equation by? 3. Very good. So I'm taking this and I'm multiplying by 3. I'm going to put my work down here just so it stays nice and neat. So 3 times negative X is negative 3X. 3 times 5Y is 15Y. 3 times the 3Z, 9Z. And 3 times 2 is 6. So we multiplied 3 times everything in that second equation. I don't have to multiply the third equation because all I was looking for was negative 3 and positive 3 for the X's. So I'm just going to rewrite this one underneath so that we have our work all nice and neat. So we're looking at the second and the third. We multiplied the second times 3, so we have 3X and negative 3X. And now we're ready to add them together. All right. X's eliminate, yes? How many y do we have left? 13y. How many z do we have left? 5. And what do we have as a number on the other side? 24. So we now have two equations that have yz equals a number. I have this 13y plus 5z equals 24. I have a negative y plus a positive z equals the negative 6. So now we're looking at these two equations, and we're going to ask ourselves, what do we want to eliminate now? Do we want to eliminate a y or a z? Question mark. Y or z? Which one do we want to eliminate? Y. Does it truly matter if somebody were to say z? No. Okay? Because this one is a negative 1 and a positive 1, those are easily changed to those opposites of these 13 and 5s. Okay? So I heard y because it's already negative. This one down here is positive 13. So if we're going to cancel out y's, what does this green one need to become? 13, right? It's already negative, but we need a positive and a negative 13, correct? All right, so I'm going to multiply this one up here by 13, and I'm going to go down below. 13 times negative 1 is negative 13y. 13 times 1z is 13z. Again, 13 times negative 6. I am not a human calculator. What is negative 6 times 13? Negative 78. I heard it twice. I'm going with it. 13 times everything here gives me a new equation. I'm now going to just rewrite that equation, this one here, underneath, so we keep our work all nice and neat. So 13y stays the same. 5z equals 24. So right here, we multiplied to get the negative 13y, 13z, and negative 78. Here we're not changing it. Now we're ready to add them together. Y's cancel out. How many z do we have left? 18. Equals, what number do I have? Negative something. 54, good math. And we divide by 18. Divide by 18. All right, negative 3. We know that I need a x, a y, and a z alphabetically. I have only a z. I need to take that z and I need to plug it in either here with the two variables or here with the two variables, but I only have z. Do we want to go into the green z or the pink z? Green or pink? Pink? Sure. All right, so we're going to go in here, and we have 13y plus 5 times my negative 3 equals 24. That gives me negative 15. Moving it to the other side would be doing what? Adding. What I do to one side, I do to the other. I get 13y equals 39. Y is going to equal what? 3. See why I'm saying separate sheet of paper needed? Now we have a y and a z. We need our x, so we go back into one of the original equations. We have my z. We have my y. I need to go back and substitute into the original equations to solve for the third variable. Do we want to go in the first, second, or third equation? Which one? Third? All right. So here is my z. What did we solve for? Here is my y, and I want my x. All right, so 3x minus 2 times my y, which was 3. Negative 4 times my z, which was negative 3. And then equals 18. All right, just making sure we're still on there. 3x minus 6, doing the math here, plus 12, doing the math there, equals 18. 3x plus 6, because negative 6 and positive 12, equals 18. Moving my 6 over would be subtracting. And 3x equals 12. So 3 into both of those numbers gives me x equals 4. Once we get all of those, we think about it. It has to be in order triple. So we want x, y, z alphabetically. So how does that order triple go?
4, 3, and -3.
Very good. And that would be our answer. Let's go back and revisit this whole problem. Again, what is your homework off of that worksheet? How many do you have to do?
5.
Only 5. You choose the 5. Okay? Going back to the original. Okay, we had 3 variables in all 3 equations. Hence, it was a system of 3 by 3's. I then said when we choose, we need to choose the variable we want to eliminate out of all 3 equations. And I believe we chose x. Okay? We can only look at 2 equations together at a time, so we did. And we got that y, negative y plus z equals negative 6. We looked at the bottom 2 equations. We did have to multiply by a 3 so that we had a negative 3x and a positive 3x. We got a new equation of 13y plus 5z equals 24. So we did elimination. We then chose elimination again. So it's double elimination on the harder ones. And we said, what do we want to eliminate? And I heard y. So we multiplied the green equation by 13, added it with that pink equation, got our z. Once you get z, you go back into the equations that have 2 variables, so then substitution. Get a second variable. Once we get 2 variables, then we go back and we substitute into one of the original equations to find that 3rd variable. Okay? And once we get that, we have our solution. Okay? 5 from that worksheet. Only 5, but yes, show work on a separate sheet of paper. Again, you can check Canvas modules